Hello everybody, Root Beer here, and I'm looking at question number 22 on our 2016 Grade 8 Gauss paper. So this is the first question in Part C. The questions are worth a bit more. Part B questions worth 6. Well, now these questions are worth 8, so we want to do well, but we want to get, and we want to do it quickly so that we have time to do all 5, because these are the harder questions on the contest. Alright, so question 21. Two 5-digit positive integers are formed using each of the digits from 0 through 9. Exactly once. What is the smallest possible positive difference between the two integers? So we want the smallest difference between these two integers. So we want to make these 5-digit numbers as close as possible. And looking at the answers here, one of them has to be right. These are actually pretty close. So how do you make numbers really, really close? Well, I suppose, think of it, because we're not allowed to have the same digits, so it's not like we could do, 4,000 or 40,000 and then 40,001. You're only allowed 1 4. You're only allowed 1 0. You have to use each of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 exactly once. So we can't just pick numbers really close like that. Okay? But if we're so whatever number, if we start with a 40,000, okay, 4, it doesn't have to be a 4. We could start with a 7. I don't know what's actually going to turn out to be best. But what's the, numbers that are close to that are also in the 70,000s, and then the next closest thing would be an 80,000 or a 60,000. Right? Because we're not allowed to use 7 again, so the second number either has to start with a 6 or an 8. That's the sort of reasoning here. And then, well, that looks like you're off by about 10,000. I don't know what the other digits are yet. But it looks like you're off by 10,000. Unless you start doing things like, say, well, let's make it 79 and an 80, and then suddenly things are getting really close. Okay, so if I do something like that, how else could we get close? Well, we could... I guess we want to try and make this number as small as possible while making this number as big as possible. So how else can I make numbers big? Well, numbers get bigger. If you read from left to right, you want bigger numbers earlier on. So what's the next biggest number? Because we've already used 9, 8, and 7, and 0. I suppose we could use a 6 here, and a 1 here, and maybe a 2, and a 3, and a 5, and a 4. I mean, that's pretty close. That's within a couple hundred of each other, but it's not quite good enough. But, it's an admirable first try. Problem here is, when I went to use 79, I had 7, 9, the next thing I really should have done is use sort of an 8 here. Because if I had something in the 800s, that'd be much closer than the 600s. So, instead of picking the first 2 digits, let's leave those blank. We'll want them to be close. We'll want them to differ by 1. But we definitely want the next one to be a 9 and an 8 and a 7 and a 6, because that will make as big a number as we possibly can get, and that'll be as close to the second number as possible. And we want the second number, the bigger of the two, to be as small as possible. So that'd be 0s and 1s and 2s and 3s. Okay? And when we do that, that sort of leaves us with only 5 and 4. Well, 4 should go here, and 5 should go here. And then, well, that seems kind of reasonable. How close is that exactly? Of course, we can get out a calculator if we want to. But we could also just subtract, borrow a 1 from here, 7. Borrow a 1 from here, 4. Borrow some 1s from here, 49 minus 49. So 247 is what this attempt has given me, 247. And in terms of answers, well, that's pretty darn close. It's better than E, B, A. Only D is closer. Only D is sort of smaller. And we are looking for the smallest. But I'm really confident in the numbers we chose, and I have reasons for why I went 9, 8, 7, and 6. And 0, 1, 2, and 3. Now I can try playing around with these to make the numbers smaller, but I think the best insight we had was that the first number really doesn't matter. We just need them to differ by 1. But then the next 4 need to make as big a number as possible. Well, this is the biggest 4-digit number you can have, without repeating digits, and this is the smallest 4-digit number you can have without repeating digits and allowing for a leading 0. So this really is the best we can do. Okay? Now, we can't really try all the possibilities and hope we get a 229. I don't think a 229 is doable, simply because, well, sometimes what happens on these contests is when they ask for the smallest, they'll put in a number that's automatically lower, so that people don't just guess D and then move on. Okay? You have to do a little bit of work. Sometimes it's the second lowest, sometimes it's the third lowest. Although sometimes they make the smallest one possible because they think people know that trick. Okay? But, I'm definitely confident in our 247, so I'm going to say our answer is C. I've got reasoning to back it up, and that's all you really need in math. You need logical, nice, clean reasoning and good calculations. And hopefully we'll have good reasoning and good calculations in the next video as we look at question 22.